You know, the rules of war are changing so fast right now. It's really not about who has the most advanced fighter jet or the biggest battleship anymore. There's this new, way cheaper weapon that's rewriting the entire economic playbook of modern conflict, and it all starts with one simple question.
So really, think about it. How do you take down a state-of-the-art $4 million air defense missile? The answer is so simple, it's kind of shocking. And frankly, it's pretty terrifying for military planners everywhere.
You do it with a drone that costs just $20,000. That's it, 20 grand. This is the brand new economic reality of the battlefield, and believe me, it is turning decades of military strategy completely on its head.
And that brings us to the new rules of war. The absolute best example of this whole shift is Iran's Shahed 136. Look, it's not a technological marvel. It's slow, it's pretty loud, but its real power, that lies in its price tag.
Just look at this crazy imbalance. A defender fires off a $3 to $4 million Patriot missile to stop a drone that costs, what, $50,000 at most? I mean, you don't have to be an economist to see that this math is just completely unsustainable. And the strategy, it has a name: financial attrition.
So here's the crucial point. The goal isn't just about destroying a target anymore. It's about making your enemy go broke just trying to defend themselves. You're forcing them to burn through their entire stockpile of multi-million-dollar missiles to stop waves of what are basically flying lawnmower engines with some explosives strapped on. You win by bankrupting their arsenal. It's brilliant, in a way.
For a little while, this asymmetric advantage seemed almost unbeatable. So how did the world's most advanced military decide to respond? Well, instead of inventing some new multi-billion-dollar superweapon to counter it, they did something nobody saw coming. They decided to join the game.
This quote from Admiral Brad Cooper, it tells the whole story perfectly. They didn't just study the Shahed. No, they copied it, they improved it, and they turned it into their very own weapon, the Lucas drone. It was the ultimate case of, if you can't beat them, join them, by building a better, cheaper version of their own weapon. But what's really staggering here is the speed. From an idea to actual combat in just 18 months. Now, in the world of defense procurement, where programs can literally take decades, this is light speed. It just proves that when the need is urgent enough, the old rulebook gets thrown right out the window.
So this whole rapid adaptive model, it provides a really powerful blueprint for India. For a nation that's managing thousands of kilometers of hostile borders, developing a sovereign, long-range, and affordable attack drone isn't just a nice-to-have. It's an absolutely critical strategic necessity. So let's try and design one. We'll call it the Vajra.
Okay, so how would you actually design this thing? Well, you'd start by learning from the best, right? The ideal Vajra would basically combine all the best features you see here. You'd want the incredible range and payload of the Shahed. That's a one-way attack or OWA drone, but, and this is the important part, you'd build it with the cost efficiency of the American UCAV. It needs to be a long-range strategic weapon, not a short-range thing like the Nagastra.
But look, building an effective drone for India isn't just about copying and pasting a foreign design. It has to be engineered for India's really unique and demanding strategic environment. I mean, we're talking about everything from the highest mountains in the world to the vast expanse of the Indian Ocean.
This chart right here visualizes a massive engineering problem. A standard piston engine, like the one in a Shahed or a Lucas, loses almost half its power at 20,000 feet. The thin air of the Himalayas would just cripple it. So this is where a turbojet becomes absolutely essential. The ideal Indian drone would need a modular design, one that lets you swap between engine types depending on the mission.
The other critical piece of the puzzle is navigation. Just relying on foreign GPS is a major vulnerability. So, integrating India's own NAVIC system is a total game changer. Because its satellites are directly overhead, the signal is way stronger in those deep Himalayan valleys. It gives you sovereign, jam-resistant, sub-meter accuracy, which is absolutely vital for precision strikes.
All right, so we've got the design down, but here's the hardest part: actually building them. In this new era of warfare, the ability to manufacture thousands of these things cheaply and quickly, that is a strategic weapon all by itself. It's all about creating what they call affordable mass.
And this is the magic number: $35,000. This is the benchmark that the U.S. Lucas program set. It's the price point that makes that whole strategy of financial attrition even possible. And hitting this number isn't just an engineering goal, it's an industrial one.
So how do you get there?
Well, this isn't about traditional, slow-moving defense manufacturing. Not at all. It's about adopting what's called a Shanzai model, this philosophy of rapid reverse engineering and then improving on it, just like the US did. You have to secure your supply chain by cutting out unreliable foreign parts. You use low-cost commercial electronics, and you leverage modern techniques like 3D printing. It's not about inventing the wheel. It's about making a better, cheaper wheel, faster than anyone else can.
Okay, so let's bring this all together. What happens when you actually have thousands of these $35,000 attack drones? How does that fundamentally change the way you fight a war?
Well, this is where it gets really interesting. You don't just send them out one by one. You send them in waves for missions called SEED. That's Suppression of Enemy Air Defenses. These cheap drones basically act like bait, forcing the enemy to turn on their radars and fire their expensive missiles. And once those defenses are depleted, you send in your high-end stealth assets, like a UCAV, to finish the job. Or, even better, you launch AI-coordinated swarms that are just too numerous and too complex to defend against.
And all of this brings us to the final, crucial question. The lesson from the Shahed, from the Lucas, and from this blueprint for an Indian drone is that the very nature of power is shifting, and it forces us to ask, will the next war be won not by the country with the most advanced tech, but by the one that can simply build and deploy faster than anyone else?